Okay, the next section is section 5.2, and it talks about perpendicular bisector, angle bisector, and their converses. And so we're going to write the theorem, so I'm going to show you the picture or example, and then you're going to have some applications down at the bottom of your sheet. So let's go ahead and write what the perpendicular bisector theorem states. It states that if a point is on the perpendicular bisector of a segment, then it is equidistant meaning equal distance from the endpoints of the segment. So here is your perpendicular bisector, and we know it's the perpendicular bisector because we see this right angle and we see two congruent marks on either side. And so what this is saying, if a point, we'll call this point X, is on the perpendicular bisector of a segment, then it is equidistant from the endpoints. Okay, in other words, this X is the same distance from X to A as it is from X to B, and you see that right here. Okay, so again, if you have a point on the perpendicular bisector, then it means that it is the same distance from each of the endpoints. It doesn't have to be right there, it could be up here, and it's still going to be the same distance from X to B as it is from X to A. So it doesn't matter where on the perpendicular bisector, it's still going to be equidistant. Okay, let's talk about the converse then. Remember, it just switches the hypothesis and the conclusion. What the converse says is if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. Okay, so I'll show you what it means. Let's say we're starting with X, and we know that the distance from X to C is 4, and that the distance from X to D is 4. So if this point is equidistant to each of the endpoints, then we can conclude then that X lies on the perpendicular bisector. And you can go ahead and make your marks that this is the perpendicular. Okay, I'm not really sure. I had to back up. There was a helicopter and all of that. So converse of perpendicular bisector theorem, if X is equidistant from the endpoints C and D, then we can conclude that it is on the perpendicular bisector, and we can go ahead and make our right angle marks and our midpoint marks. Now, moving on to this next section, what you notice is that there are right angles that are formed here. And before we discuss angle bisector theorem and its converse, we need to talk about why these right angles are here. And basically the reason that the right angles are here is that the distance between a point, X, and a line or a ray or a segment always creates right angles. So anytime we're talking about the distance between a point and an actual line or a ray, that distance will always be perpendicular, will always form right angles. So let's talk about what the angle bisector theorem states. It is if a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. Okay, so we have this point X, and we know that this is the angle bisector because we've seen these two marks, okay? And so X is on the bisector of the angle, then we can go ahead and conclude that the distance from X to this side, right here, is the same as the distance from X to this side, as noted with AX being 4 and CX being 4. The converse of the angle bisector theorem says if a point in the interior of an angle is equidistant from the sides of the angle, then the point is on the angle bisector. And we have to draw our own picture for this, and so what I want you to do is I want you to draw angle PQR. So we're going to draw this, and we're going to label it PQR. And I give you this point X, and I tell you that the distance from X to P is 5, and the distance from X to R is 5. And so we know that this segment XP and this segment XR are congruent. So what the converse says is that if a point on the interior of an angle or the inside of an angle is equidistant to the sides, then we can conclude that the line drawn through this X from Q to X is the angle bisector, and it cuts that angle into two equal parts. Now again, I want you to know we were talking about the distance from a point to this side over here, so a right angle would be formed here and a right angle would be formed here. So again, if a point on the inside of an angle is equidistant from each side, then the point is on the angle bisector. Now, I want to see if you can hit pause and you try numbers 1 through 4. I do realize they may be a little more difficult. Try them, see what you can do, and then I will discuss them as soon as you hit play again. Okay, number 1 says to find the value of X, and so X deals with these two segments right here, and so we have to just look, ignore a whole lot of the other stuff and look at what we're. So again, we have to look at what we're given, and we're talking about X. And so we look at this right here, and it looks like BD is the perpendicular bisector of AC. And I know this because there's a right angle here, which means I can put a right angle in all 4 spots. And so right angles are formed, and G is the midpoint of AC. So due to the perpendicular bisector theorem, I know that AD is equal to CD. And so I can say that 2x minus 3 is the same as, or the same distance as x plus 2. And whenever I solve, I get x to equal 5. Now, some of you will look at this and say, well, aren't these two triangles congruent? And because these two triangles are congruent, I can use congruent parts of congruent triangles congruent and just assume that AD is the same as CD, and that is an okay way to look at it as well. So if I find that x is 5, then to find the length of AD, I just have to substitute 5 in for x, and I get the length of AD to be 7. Now, when we're looking for y, we just look at what we're given. So in just a second, pause it and look at what exactly you're given when it deals with y. So pause it right now and see what you're given. So y plus 5 and 3y are right here. And it looks as if G is on the angle bisector of EBF, or ABC. So if G is on the angle bisector, I can see because these angles are congruent. If G is on the angle bisector, then the angle bisector theorem says then the point is equidistant from the sides. In other words, G and F have the same distance as GE. So I could say that y plus 5 is the same as 3y. And when I solve that, I get y to equal 5 over 2, or 2.5. And when I substitute in to find EG, I get 2.5 plus 5, which is 7.5, or 15 over 2.